Let's solve this problem using third approach, and I can say this is the best approach. In the last two videos I solved this problem using a different way. So one first approach is a recursion and dynamic programming, and the second approach was the DP array. And today we'll use a third approach, and the third approach is using the DP and the dynamic programming, but there is a little bit change, and I will explain why this is the best approach here. So let's understand this problem once again. And if you have not watched other two videos, you can just go to the playlist logic building and you can find the two videos, approach 1 and approach 2, for the word break, and you can come back here. And the problem here is there is a string LeetCode and there is a dictionary Leet and code, and we want to know if the string can return true if this word exists in contiguously, and you can break this word. So if I take the Leet here, so I can say Leet exists here, and you can take another word code, the code also exists, and then string ends. So we can return true here. In this case, apple, so apple, that's also in a word dictionary, and apple exists, and there is a pen, and pen also exists here, and then again apple, and apple can also exist here, so we can return true. In this case, cats, there is a cats exist, and then there is a and also exist here in this dictionary and in the string, and the OG not in a dictionary. I can try with another combination cat, okay, cat exists here, and then I can try with the sand also exists, OG doesn't exist, so we can return false. In the previous approaches with the dynamic programming where I use recursion, I was iterating through each character of this main string, and then I found some word in this dictionary, and again I started iterating with other characters. Again I take this word and check in a dictionary if that exists or not, and if it exists, and we reached at the end and we returned true. So that's the strategy I used, but in this video our strategy is we'll not iterate through this letter, but we'll iterate through the word dictionary, and we'll get the Leet, and then we'll check to the main string that Leet exists or not from the 0 to length of this word, and that exists. And then again we'll call the recursion with a new string, and new string contains code, and again in a recursion we'll iterate through, and the code exists, we return true, and then we call again recursion, another recursion, and in that case our new string will be empty, and then we return true there, and then finally we can return true. So we'll use that approach. So the code is here. So in a code I'm just checking this is our best condition, because we eventually will come to the end of this string, and if that's the case we can return true. That's the DP array like the first video, but main logic is here. For this approach I'm iterating through words itself, so we'll get the Leet first, and we'll check length of a string greater than equal to length of word. So the first time Leet, and of course this length is greater than equal to that condition match, and then from 0 to length word I will get the word from this string. So 0 to length of word, that is Leet, so we'll get this Leet and that match. Then we'll call the recursion, and in the recursion our new string will be just code. So the code, how can I get the new string? That is from length of word, that is length of word. So we got the Leet, so first we got that Leet, then the length of word we just extracted from that, and from the new string will be from here itself. So that's a new word, and then we'll call the recursion, and then we'll come back here and we'll get the code will match, and then we'll return true. And yeah, this much is very much similar to the first video, only the difference is this time I'm iterating through this word dictionary. So that's all for now. Thank you.